Hi everyone. So today we are going to discuss chapter 8, which is Zeroth Law of Thermodynamics. So temperature is a very essential component in thermodynamics. Basically, temperature is what separates thermodynamics from other form of science because we always talk about temperature. Everything is surrounding around temperature of the body. And also temperature is very important to associate or distinguish what is hot, what is cold, right? So what Zeroth law says is when there are two different bodies and they have two different temperatures. When they are brought into contact, after some time they will attain a common temperature. Okay? There will be a transfer of temperature from one body to another. After some time they will attain a common temperature and then they will be in equilibrium. So in figure here, I have a body A which is at temperature T1, then I have a body B which is at temperature T2. Let's say T1 is higher than T2. And then we will discuss in second law of thermodynamics that there is a heat flow from hot to cold. So there will be a temperature transfer from body A to body B, and A and B will come in thermal equilibrium when they are made in contact with each other. And they might attain a temperature which is, let's say, T3. So this is a temperature. T3 is a temperature of combined A and B. Now what Zeroth law further extends is if there is a body C and this body C is in thermal equilibrium with A. So I have to draw here again. So if this is A, this is B, this is C. What this Zeroth law says is if A was in thermal equilibrium with C and now A is also in thermal equilibrium with B, this implies that B and C are also in thermal equilibrium. This is what Zeroth law is. So if A and B are brought in contact, they attain a temperature T3, which was some average temperature. There was a transfer in between the two. Now let's say this is T4 and T1 and T4 combined together and they achieved a separate temperature. Now if we combine B and C, they will also be in thermal equilibrium with each other if A and C are in thermal equilibrium with each other. So all three will exist at the same temperature. So that's what the Zeroth law is. And this is the definition of Zeroth law. Now, why Zeroth law? Why we are studying Zeroth law? Because it is important for measurement of temperature. That's our next topic to discuss. So the temperature measurement, why we are discussing this? We always talk about temperature in thermodynamics. Now, but have we really understood why we are taking temperature measurements and what are the different types of methods which are used for taking temperatures? Is there a reference body which is used? So let's discuss that. Basically, whenever we are doing temperature measurement, a reference body is taken. And then we see, is there any physical characteristics which is changing with change in temperature? What that means is, let's say I fill, there is a thermometer, okay, which is a mercury thermometer. So the mercury is filled on this thermometer, and then I made it in contact with the hot water. Now, when it went in contact with the hot water, the mercury level rise. So the change in physical characteristic was length, right? So with change in temperature, the length changed. If let's say this temperature was T1, length might change to some L1. If this was T2, length might change to L2. Similarly, so there is a correlation between the two properties. So this is how temperature measurement is done. Always a reference body is taken and a physical characteristics which changes with temperature is taken. Now, few different methods which are used for temperature measurements, and this broadly classify all the different methods right now. So you have to take a physical characteristic, a thermodynamic property. Okay, both are same. Now you see if it is changing with the change in temperature. So one device could be, we discussed mercury-based thermometer. So that is length, or these are also called capillary temperature measurement devices because there is a capillary action going on. The length is increasing and you are measuring that physical characteristics and relating that to change in temperature. Other device which measures temperature could be thermal EMF. So you see what is the potential of a body at one point. Now you apply temperature to it, you study potential of body at other point. So you see in terms of change in potential, you can calculate how much was the change in temperature. So this is how you measure using thermal EMF. Resistance, you have resistant thermometers. If there is a change in resistance, there are many different types of metals whose resistance changes when the temperature is applied, when they are heated. If resistance changes, then you can simply say, you can correlate the change in resistance is similar to change in temperature. Volume. So if there is a gas present in a contained um, space and you increase the temperature, the molecules get excited, the volume increases, there will be change in volume. So V2 minus V1 will correlate to change in temperature. And then finally, there is a pressure measurement devices where pressure will change when the temperature is changed. So this will say P2 minus P1. So this is how we are measuring temperature. These are the 5 different categories which are used right now. These are the typical temperature measurement devices: pressure, volume, resistance, thermal EMF, length. And all the thermometers are designed around these. Now, always there is some level of inaccuracies because of the mechanical nature of all these. When you design a pressure meter, let's say, it is designed in such a way that there will be a mechanical movement of one part. Or if you are designing a length thermometer, there might be a mechanical movement or there might be friction between the walls, something of other, but that inaccuracies is accounted for and it is very small, which can be neglected in general cases. In high reality cases where there is a even the decimal or the places after decimal also affect the final calculation, they will take into that account and they will design more precise measurement devices, but using all these 5 thermodynamic properties. So this is how the temperature measurement is done. So we will end this lecture here. If you like the video, please subscribe to the channel and also share it among your friends who may enjoy the similar content. And we will meet you on the next video, where we will discuss ideal gas and its characteristics. Thank you.